Hey guys, this is IB Tutorials. My name is Josh, and I'm going to be doing a quick math tutorial here on logarithms. I'm going to be going over some basic rules for logs that you need to know, and then I'll just do a few IB questions that you're most likely to encounter during your time in the IB. So let's start. The first thing you need to know about logs is that basically log is an exponent. Alright? So just always keep that in mind. What I mean by this is if you do log base a b equals x, this can be written as a to the power x equals b. Alright? You need to know this because it's going to come up a lot. So just always never forget this, alright? Just keep this in mind at all times because, yeah, it's very important. Alright. From this, there's a few more rules that come up, and those are log a base a1 equals 0. Alright, from the first rule this can be seen because if you do a to the power of 0, well, that equals 1. So this law, whenever you have 1 here, no matter what base, it always equals 0. Alright, and if you have log a and a, so same as the base, if this number is the same as the base, it always equals 1. If you can see this when you do a to the power 1 equals a. Very simple stuff here. And some more important rules here. I'm just going through the basic rules here. I'm not going to do every single one, I don't think. If you do log base a x times y, this can be written as log base a x plus log base a y. Alright, so if it's multiplication here, you can write it as addition in this form. Alright, same for division. Instead of addition, you change it into subtraction. So log x over y equals log base a x minus log base b y. Alright, so these 4 rules are basically the main rules that you need to know. There are a couple more rules that I'll tell you now. That one is if you have log base a b to the power of n, this can be written as n times log base a b. Alright, all you have to do, if you have an exponent up here, you bring it down here and then you multiply. Alright, that's a very important rule as well. And the last rule I will do quickly here, one second, is the change of base rule. This one is very important because if they give you a question and the logarithms don't have the same base, you're gonna have to first change it into a common base. Alright, so the rule for that one is log base a b, and if you want to change that into a new base, we'll call the new base c, then you would have to do log base c. Hold on, my bad. Log base a b would equal log c, new base, over log c a. Alright, this is very important, and you will see why in one of the questions that I will do. And yeah, those are the basic rules that you need to know for the logs, and if you know these, you can pretty much answer any log question that you will encounter in the IB. And most of these are in the data booklets, except I think this one and these two rules. Alright, so let's jump into the questions here. This question is a very common question that you will always see in the IB. I've seen every exam and test that I do, I see at least one of these. So it's good to know how to do them, and they're very easy, and it's just easy marks for this one. So it says here, if log base A2 equals x and log base A5 equals y, find in terms of x and y expressions for log base 2 5 and log base A 20. So for the first one, what you basically need to do first is get the same base as what they're asking for. So you use the change of base rule, which was, if you don't remember, this log CA. Alright, that's a C, sorry. So for this one, what you need to do basically is to just change the base to A. So log base A 5 over log base A 2. Alright, so once you change the base, it's given here that log base A 2 equals x and log base A 5 equals y. So basically what you have to do here is just substitute x and y for these. So the answer will be y over x. Alright, that's pretty easy. This is a very common question, so just know the steps for these. Part B, this is pretty easy. All you have to do is split the 20. You're going to be using this rule here, multiplication, and change to addition. So it's going to be log base A. For 20 you can do 5 times 4. So you can split this into log base A5 plus log base A4. This 4 can be simplified into 2 to the power of 2. So it will be log base A5 plus log base A to the power of 2. And now for this log over here, just use this rule right here. So it will be log base A5 plus 2 log A2. So the answer for this one is y plus 2x. Alright, these are pretty easy. Once again, they come up a lot in the IB, and it's just very easy marks here. I'll do another similar question to this one, just with different numbers, of course. Yeah, except now it's just given that log base 5x equals y, express each of the following in terms of y, okay? So let's just do A here. Once again, I'm going to be using this rule here for this one, for the part A, which is log base 5x squared. So this can just be written as 2 log base 5x, which then equals y. That's it. Pretty easy. Part B is log 5 base 5 1 over x. For this one, you can just write 1 over x as x to the power of negative 1. That's the same thing. So you do log 5 base 5 x to the power of negative 1. Just write this as negative 1. Again, you bring this down over here. Negative 1 log 5x. Yeah, so this one, the answer for this one is negative y. Pretty easy. For the last one, log base 25x. Here we need to change the base to 5, so you just use that change the base rule, and you will get log 5x over log 525, and now log base 525 can be written as sorry, I'm running out of room here. Log base 5x over log base 5 over 5. We know that if you have this number is the same as the base, it equals 1, so it's 2 times 1. Therefore, the answer for C is, looking at this, answer for C is y over 2. Alright, so just keep in mind the steps for these questions, very easy. So yeah, just remember the steps for this. Alright, next, slightly more difficult question. This one, it says solve this equation. Alright, this is very easy if you just use this rule here, this one. So first you have to check that we have the same base, and for this question we actually do. So we can just change this into multiplication, right? So log base 981 times 1 over 9 times 3 equals log 9x. And okay, 81 times 1 over 9 equals 9. 9 times 3 equals 27. So it's log base 927 equals log base 9x. Alright? So now you can basically see here that x equals 27. To double check, you can just do, you can solve this if you want on the calculator. This equals 1.5. So 1.5 equals log base 9x. And if you just remember this rule here, we can write it as an exponent. You get 9 to the power 1.5 equals x. So x equals 27. Alright, and pretty easy question, just following the rules. And yeah, I'll do one more question here. It's a bit more tricky, this question, because you can see here that we don't have the same base. These types of questions, this one doesn't really come up, but I have seen it once or twice in the IB exams, and as long as you know the steps for this one, it's a very easy question. So let's do it. The first here, you can see we don't have the same base, so the first step for this question is to actually get a common base for this question, and for this one we're gonna get the common base of 3. So we right here, hold on, zoom in a bit. So log base 3x minus log base 9 over log base 3x equals 1. Alright, for this one I just basically use this rule again, where you go log base AB equals log new base B over new base A, right? This basic rule here. So what you have to do for this one is log base 9. It can be written as, well, it's pretty easy. You can see that it must equal 2. But if you can't see it right away, what you can just do is just write it as log base 3 squared, which equals log 2 log 3 base 3. So once again, we have these are the same. It equals 1, so 2 times 1 equals 2. So over here we get log base 3x minus 2 over log base 3x equals 1. Alright, so now here we're gonna have to just multiply this fraction. So like you would just like you would with more fractions, you would cross multiply. Just imagine this is log base 3x over 1, so just cross multiply these, and then you get log base 3x times log base 3x minus 2 divided by log base 3x, and then all this equals 1. Alright, so now to get rid of this fraction, we're just gonna move it over to this side. So just multiply it over here, multiply this on each side. So you end up with log base 3x log base 3x minus 2 equals log base 3x. Alright, so I'm running out of space here. I'm going to go to the next page. So now that you have this formula here, you have to sort of first this can be written as log base 3x bracket squared, because it's just the same thing here, minus 2 equals log base 3x. Alright, so now move the log base 3x onto the left side here. So we end up with log base 3x bracket squared minus log base 3x minus 2 equals 0. Right? Here we need to, now, very important step here, you sort of have to see it, but what you have to do is change it into a quadratic formula. So you take log base 3x and then you let it equal just a, we'll say a for this time, for this question. So we end up with a squared minus a minus 2 equals 0, right? And if you work this out, you will end up with a equals 2 and a equals -1. Alright, and now once you solve this little equation here, you plug the logarithm back in. So you have on this side log base 3x equals 2, and then on the other side you get log base 3x equals -1. Alright, so now just using once again this first rule that we went over, we can see that this side over here, 3 to the power 2 equals x, and then 3 to the power of -1 equals x. So therefore x equals 9 and x equals 1/3. Alright guys, that's it for the logarithms. I will be doing a few more tutorial videos. Tell me what you guys think, what I should work on, and yeah, good luck with your IB. Later.